Yeah, so continuing on the uh, propeller chapter. So here we're gonna do some differences between coarse pitch and fine pitch. Okay, so let's discuss it from the exam point of view, right? So that we remember stuff and then you can reproduce it in the exam. So coarse pitch is high pitch, high blade angle, low RPM, used for cruise. Fine pitch is low pitch, low blade angle, high RPM, used for takeoff, climb, to start engine. Okay, now so how do you remember this? So it's an easy way I've got. How do you remember it? Coarse starts with C, so remember it for cruise. Okay, and then coarse has higher number of words. Okay, so I mean this must be a stupid way to remember, but that's the way you'll remember it forever. 1 2 3 4 5 6, whatever, they have 6 letters, so hence it is more letters. So high pitch, high blade angle. This way you'll never forget it whenever asked to asked in exam point of view. And the other way is opposite, and just the RPM is the one that is low. Okay, because in the cruise anyways your RPM will be low, right? So that's how you can remember. So an aircraft should never be taken off in coarse pitch because it'll experience loss of power. Alright, and aircraft is supposed to be switched off. When it is switched off, it should be switched off on fine pitch to have lesser load on the next run. Whenever it started again, there is less load. Now there's something just ground fine pitch. When you're on the ground fine pitch is 0. Okay, and the blade angle and in-flight fine pitch is greater than 0. So the 0 degree blade angle, I mean, and the in-flight fine pitch will be greater than 0 degree blade angle. Okay, so now what is exactly pitch? Okay, so first I'll just draw a diagram so that we can just connect to it. So these are propellers basically. Now pitch is distance traveled by prop in one revolution. Okay, so that is pitch. Now there's something called as there are 3 terms related to this, and that is theoretical pitch, effective pitch, and slip, propeller slip. So now theoretical pitch is the whole distance, actual distance. Now not the actual distance, the theoretical pitch is the pitch that the propeller will travel if there was no friction like the air. Okay, so this is theoretical pitch. It does not exist, it's just a definite, it is not possible because there is friction in the air. Alright, theoretical pitch is also called your geometric pitch. Okay, so this is theoretical pitch, but due to there is friction due to the fluid or the air basically, so the propeller actually does not travel the theoretical pitch. It travels something of this, that is your practical pitch. Practical or effective, any of the terms, practical or effective pitch. So this is the actual effective pitch that the propeller travels. This gap is called your propeller slip. Okay, so practical effective pitch is always less than the theoretical geometric pitch, because this will happen in a perfect fluid where there is no friction, but that is just theoretical, it's not going to happen. Alright, so that's what are these 3 definitions generally asked in the exams. Okay, so let's go on to the last but a smaller part of propellers. comes into more of a piston part of it, but it's okay, we can discuss it right across. So propellers are divided into three categories also here. So they are fixed pitch, variable pitch, and CSU propellers. Now CSU is constant speed unit. Alright, constant speed unit. Now this is variable pitch is further divided into adjustable, controllable. So controllable means you are in the air, you can change the pitch in the air according to your requirements. Adjustable can be adjusted only on the ground. Okay, so that's what it is. Now when you increase, now how when you fly a multi-engine with a variable pitch propeller, so how do you increase power? So these are few steps. Just when you increase power, throttle first, then MAP or the manifold pressure. Okay, and if you're decreasing power, MAP first, then throttle. So this has to be followed. Okay, now there's something called CTM. This is coarse to fine pitch. This is decreasing blade angle. And then there is ATM. This is fine to coarse pitch. This is increasing blade angle. Okay. And now we'll discuss what is feathering. There's a concept called feathering. You feather the prop. Okay, so feathering, it is extreme coarse pitch. Okay, blade angle almost 90 degrees to the airflow, and the cord, prop cord, is parallel to the airflow. And what is the importance of feathering? Feathering reduces drag and prevents damage to a windmilling prop. So this is basically, feathering is used during your engine failure. Basically that's when you actually use feathering. Okay, now there's some two concept here. Alpha range, when feathering to fine pitch, so 90 degrees to 0 degrees. There's this beta range. This is fine to reverse. So this is used for only for ground handling and services. Okay, so now we'll discuss fixed pitch. You guys know variable pitch. I just discussed some points on that. This is more than enough for you guys at the moment, and for further you can obviously refer the books. Now we'll discuss CSU. That's the constant speed prop, constant speed unit rather. So yeah, so constant speed unit propeller. Okay, so constant speed unit propeller is it's a unit that's installed on the propeller system that keeps the propeller at a constant speed. So this helps in increasing your propeller efficiency. Alright, so now there's a RPM sensing device. So there's an RPM sensing device, which is the flyweight. Okay, this is going to sense the speed of the propeller, and this, when it senses the speed of the propeller, it will maintain a constant RPM of the propeller. So if if it is sensing at a higher speed of the propeller, then it will reduce the RPM and make it constant. Okay, so now how does it work? So there are three conditions. Suppose the fly weight is equal to the speeder spring force. So this speeder spring force is actually the spring that maintains keeps the RPM of the propeller. So if the fly weight, which is detecting or sensing the RPM, if it is equal to the speeder spring force, then it is called on speed condition. On speed condition, and RPM is correct. Okay, this is on speed condition. Now the second point here is, if fly weight is greater than the speeder spring force, it is called over speed condition. So basically your prop is running at a higher RPM. RPM is high. Okay, and hence you have to reduce the RPM. So this, what it does is, it sets the propeller to coarse pitch till it comes to the on speed condition. Third one, obviously you might have guessed it by now, fly weight less than speeder spring force. So this will be your under speed condition. So RPM is low, we need to increase the RPM, hence it goes to fine pitch. Okay, so that's all about constant speed unit propeller, and that's what you will be asked generally, what conditions are that keep the speed of the propeller constant. So actually we are done with the propellers, and so we'll be moving into the next part of our technical general subject, that will include our power plant basically, or the piston in the jet engines. And so I hope to make videos soon on that as well. So that's all from Subsonic Aerodynamics. I hope you guys have liked the playlists. So if you've liked